Alright, this is another problem from 3.9. This is problem number 11. It's a walkthrough proof, which can be kind of frustrating because basically they're taking you through step by step. So instead of you having the freedom to prove it as you might, they're going to make you walk through their steps step by step, and you have to choose some solutions and then also write down what you did on the right, choosing from what they give you to choose from. So anyways, they start off by saying, here is a trig identity. The trig identity is that the inverse cosecant of u is equal to pi halves minus the inverse secant of u. And using that, they would like you to figure out what is the derivative with respect to u of cosecant, inverse cosecant of u. Alright, so how we're going to do this is we're going to start with this identity, and we're also going to use this identity, which is somebody has derived what the derivative with respect to u of inverse secant of u equals. You can do this using implicit differentiation. It is a little bit tricky, but it's doable. So anyways, we're just going to take this as fact. The first step with this identity is we're going to take the derivative of both sides with respect to u. So this side is pi halves minus the inverse secant of u, also known as the arcsecant. And so we're solving for d du of cosecant minus 1 of u. So we're going to leave this side the same, but we're going to take the derivative of this side. And for this step, the choice that you pick on the right in their options is going to be take the derivative of both sides. Alright, so now on this side, we're trying to figure out how to take the derivative of it. So we know that the derivative with respect to u of cosecant, the inverse cosecant, arc cosecant of u, is equal to, and we can apply linearity and take d du of pi halves and d du of secant inverse of u separately. They call this the difference rule. I've never ever heard it called that, so it was a little confusing for me. I guess what they mean is that because there's a difference here, a subtraction, that you can apply linearity. I've just always called it linearity. I guess they have a sum rule as well as a difference rule, but that's just all a consequence of linearity. So I can take the derivative of pi halves is 0, and that's what they want you to enter in their box, minus, and then we're going to take d du of the arcsecant of u. And at this point, they want us to use this identity of the derivative of the arcsecant of u in order to solve for the derivative with respect to u of cosecant inverse of u. So what we'll do here is we're just going to fill in this formula down here. So the 0 goes away, we have a minus sign out front from here, and then we just have our identity, which is 1 over the absolute value of u times the square root of u squared minus 1. And so what you'll notice is that the arc cosecant of u function has nearly the exact same derivative as the arc secant function of u. The only difference is there's a minus sign out front. And so that is the only difference. So we've proved that the derivative with respect to u of cosecant of minus 1 of u is equal to negative 1 over the absolute value of u times the square root of u squared minus 1. And that's the final step. And so I hope this helps, and I'll see you next video.